the past 50 years, innovation has reimagined everyday life. Many of these modern technologies still rely on the same traditional materials. So, imagine what could be achieved by unlocking a whole new library of advanced materials. In 2004, the isolation of graphene, a single layer of carbon atoms, gave a glimpse into the future. Working with graphene and other 2D materials, researchers can build new designer structures with unique properties by stacking together these single atom-thick materials layer by layer.
The ultra-high vacuum system allows us to stack many naturally occurring materials on top of each other to make a library of artificial solids, which allows us to really tailor and customize the properties of the material.
Scientists started combining 2D materials from 2010 using simple micrometer-driven stages and an optical microscope. Last year, scientists at the National Graphene Institute created a world-first system, a bespoke suite for the nanofabrication and characterisation of 2D materials. The Ultra-High Vacuum Suite, funded by the Royce Institute for Advanced Materials, combines several interconnected chambers to create, analyse, process and fabricate the layered structures of the future.
So when we started, we were just using a simple optical setup to stick these layers together. Then over time, we progressed into pure argon environment. That allows us to use a lot of new materials that are otherwise unstable in the air. Now we are achieving the highest purity standard by putting this in ultra-high vacuum, where there is no chemical degradation, there is no contamination from the air, and that gives the best quality structures that we can achieve.
So the really unique part about this system is that it allows us to do many different processes all within the UHV environment. There's no need to take the sample out and expose it to air, which may ruin it. You can transport between the stacking chamber, the deposition chamber, the STM chamber for analysis.
Once we make these stacks, we're interested in characterizing them, and this can be done by a few different ways. We can look at atomically how they behave, so that's done in the STM. We can look at their optical property and their interaction with light, which is also done in the UHV in the main chamber. And then we can look at their electrical properties. So for this, the fabrication can be done mostly inside.
The suite has demonstrated a new horizon for engineering of 2D and layered materials. The next step is to analyse and exploit the potentially thousands of new materials that it can create.
The advantage of van der Waals scatter structures is that we can use hundreds of different materials and we can stack them in any combination while keeping the interfaces between them atomically clean and sharp. That is not achievable with any technology known today.